SpaceX's Raptor 3 is wild right now. It's running without a heat shield. That's like driving without brakes, but somehow it's working. I don't get it. Every other rocket engine needs protection from crazy high heat, but Elon's team just ditched the whole thing. The crazy part? When fuel leaks, it doesn't explode, it just burns off. NASA engineers are scratching their heads. This thing now makes 280 tons of thrust and weighs way less. Even the experts thought the first pictures looked busted until SpaceX fired it up. So what's the deal? What's the secret to this insane engineering? Let's get into it. Here's the thing nobody mentions. Traditional rocket engines are basically bombs with a metal jacket, the heat shield. Been that way since day one. But SpaceX engineers had a huge problem. Raptor 2 needed over 10 tons of stuff just to keep it from melting. Every launch was hauling this dead weight. It was like bringing a fire truck to deliver a pizza. With 33 engines on the super heavy booster, that's 330 tons of basically useless gear. Meanwhile, Blue Origin and ULA are going even heavier on the shielding. Then Elon said the unthinkable. What if we just skip the heat shield? Everyone went quiet. It sounded crazy, but what happened next changed everything we knew about rockets. In August 2024, at the McGregor test place in Texas, SpaceX was either going to make history or make a very expensive boom. The first Raptor 3 was sitting there, no heat shield, no fire foam, nothing. Just engine and air. Engineers were nervous as methane and oxygen mixed. It's like 350 car tires exploding all at once, but controlled. Ignition happened, and it worked. Not just worked, it worked great. But here's the crazy part that made rocket scientists question their lives. When fuel leaked, like it always does, it didn't blow up. It just burned off in the plasma. The leak became part of the fix. It's like designing a car where oil leaks make the engine run better. Shouldn't be possible after 70 years of rocket science, but there it was, working perfectly. Okay, what does this mean? Raptor 3 makes 280 tons of thrust at sea level. That's like 560 elephants shoving your rocket. In space, it jumps to 306 tons. The Apollo mission's F-1 engine made 70 bar of pressure. A Russian RD-180 makes 267 bar. Raptor 3? A crazy 350 bar. But the real deal isn't just power. It's because SpaceX cut 1,500 kilograms from each engine by ditching the heat shield. Times 33 engines on Super Heavy, and you've got 49.5 tons of extra payload. That's huge. That's the difference between making it to Mars and falling short. Every saved kilogram is a kilogram for life support, science stuff, or building a colony. Most people are missing the big picture. It's not just a better engine. It's a whole new way to build things. Old rocket engines are like cars, tons of parts bolted together that can fail. Raptor 3 uses advanced 3D printing to make stuff that was impossible before. Instead of 20 parts, they print one piece with cooling built in. Simple. But this simplicity cost a lot. SpaceX had to create new ways to build, use new materials, and check for defects. They didn't just build a better engine. They built ways to build better engines. That's when stuff got real. By May 2025, SpaceX had test-fired Raptor 3 over 300 times, for 16,000 seconds total. That's more than some engines get in their entire lives. But the real test was reusability. Traditional rocket engines are basically one-time use. Even Falcon 9 engines need a ton of work between flights, weeks, and millions of dollars. Raptor 3 is meant for 1,000 flights with little work. Car engine for space. Early tests show they're killing it, with some engines firing hundreds of times without problems. This isn't just about rockets. It's about a spacefaring civilization. Dropping heat shields isn't just about Raptor 3. It's about changing how we think about space travel. Without that weight, Starship can carry 40 extra tons to orbit. More satellites per flight. For Mars, it means more life support, gear, and supplies. It's the difference between surviving and thriving. But here's what's keeping the competition up at night. If SpaceX can ditch heat shields on rocket engines, what else is not needed? Landing legs? Fairings? Recovery systems? Entire rocket stages? The whole industry is trying to figure out what else they got wrong. What other impossible tricks are right in front of them? While everyone looked at Raptor 3, SpaceX quietly worked on something bigger in August 2024. Elon mentioned Raptor 4 could hit 380 seconds of specific impulse. That's supposed to be impossible for a chemical rocket. Word is, Raptor 4 uses everything learned from ditching the heat shield. Raptor 4 is said to make 330 tons of thrust per engine, with 35 engines per booster. That's 11,550 tons total, more than 3 Saturn V rockets. But get this, Raptor 4 might be cheaper to build than Raptor 3. Building it with no heat shield in mind from the start means a simpler design, fewer parts, and less complexity. It's not just better, it's different. The real genius of removing heat shields isn't tech, it's bucks. SpaceX thinks each Raptor 3 costs around $500,000 to make. Sounds like a lot, but other engines cost $5 to $10 million. Less parts mean less problems putting it together and easier to get parts. Faster building, more working rockets. SpaceX want to get the cost down to $250,000 per engine, while keeping the same power. It's about making space available to everyone. When launching stuff becomes like shipping, things change quickly. Space manufacturing, asteroid mining, solar power satellites, Mars colonies. Suddenly, it all makes sense. So, everyone's asking, if SpaceX can ditch heat shields from the strongest rocket engine ever, what else have we been overdoing? Fuel tanks? Navigation? Life support? Spacecraft? Everything's up for grabs. Old aerospace companies are in trouble. Do they copy SpaceX or stick to what they know? Here is more. Are we seeing a total change in how we build machines for rough places? The thinking behind Raptor 3 is here to stay and may apply to everything else too. Nuclear reactors? Deep-sea thing? Hyper-aircraft? Etc. Bottom line, SpaceX is changing everything. They didn't just lose the heat shield, they proved a long-held belief wrong and came out on top. Eliminating heat shields unlocks more, and what impossibilities are there hiding in plain sight? Also, the next rev may not be about the engine but what engines should be. So there you have it. We will be exploring more on the impossible and child's play. What are you thinking? This thing will explode or take off like a beast? Leave your thoughts below and subscribe if you would like a deeper look into space exploration. Elon just announced Starship Flight 10 will launch in late June. NASA is stressed. 2 rockets have already blown up, and Flight 9 barely made it. Now SpaceX has one chance to show this huge rocket won't explode. If it works, $10 million launches. Mars happens. Moon trips by 2027. If it fails, NASA's program dies and SpaceX is in trouble. This one flight decides if we get off Earth or stay stuck for another decade. Flight 7 didn't just crash. It tore itself apart from the inside. Vibrations caused damage that ripped apart the fuel lines. Engineers were scared as the rocket went down. Flight 8 exploded. No recovery systems. Just a flash and then nothing. Flight 9 barely made it. Temperatures were crazy high. One mistake and the program goes dark.